Hi. So here's some problems that from the book that the students gave me. Says that sine of pi over 2 plus x, excuse me, does it equal cosine of x? And it's a little bit difficult to prove. So here's what we're going to do on this. Okay. Um, we know that sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of beta alpha times sine of beta. Sine, cosine, cosine, sine, alpha, beta, alpha, beta. And just to help you out a little bit, here's my alpha and here's my beta. So that becomes, I'm going to use some shorthand notation here. That becomes the sine of pi over 2 times cosine of x plus cosine of pi over 2 times the sine of x. We do know that at pi over 2, which is 90 degrees, that the sine of that is going to turn out to be 1 right there. Meaning that 90 degrees is going to turn out to be 0 right here. So this whole term turns out to be 0. So therefore, that equals cosine of x, which is located right there. Okay, check. What about this guy? Sine of theta times cotangent of theta, does that equal cosine of theta? So in this type of situation, what you want to do is take cotangent of theta and change it into sines and cosine. Sine of theta times cotangent is the ratio function is going to be cosine of theta over sine of theta. We know that the tangent of theta is equal to sine of theta over cosine of theta. So the cotangent of theta, which is the reciprocal function, we just flip it around, which becomes cosine of theta over sine of theta. Okay, and then over 1, we notice something else. When we multiply straight across, we can actually cross these out. That becomes cosine of theta is equal to right here, cosine of theta. Check. Let's go to the next problem. Sine of x plus 2 sine of x plus cosine of x plus cosine of x, 2x, does that equal cosine of x? Took me a little while, 5 seconds to figure this out. I'm going to rewrite this as cosine of x times cosine of 2x plus sine of x times sine of 2x. The cosine of alpha minus beta is equal to cosine, cosine, sine, sine, alpha, beta, and change the sign. Oh, it kind of looks like this, doesn't it? I'm actually going to write cosine of 2x in front. Cosine of 2x, cosine of x, plus sine of 2x, sine of x. I could have actually done it this way, but it would have cost me a negative. And the cosine of negative, since it's being an even function, it just turns positive. It's a little bit more complicated this way. So I wrote it this way. Here's my alpha, beta, So that becomes cosine of alpha minus beta, which is equal to cosine of 2x. Since it's plus, we have to change it to a minus x, which becomes cosine of x. Just like it said right over there. Check. Okay. Next one. This is an equation, so you have to solve this out. Let's see how you can solve for the x value. And it says it's interval between 0 and 2 pi. So what do? We first move the 1 over by adding 1 to both sides. 2 cosine of x is equal to 1. Take that 2 out, divided by 2 right there. So what angle will give me 1/2? Cosine of what angle? So what you have to do is you have to use the unit circle. is going to be, we know that from the previous.
Answer is 0.5.
Oh my God, my Google is listening to me. So it's going to be root 4 over 2, it's the x direction, right? So it's root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2.
When you say, hey Google, or when you physically trigger me. To view your audio activity, go to myactivity.google.com.
Wow. So it's going to be here, which is going to be 60 degrees. If you want it in radians, because they want it in radians right there, 60 degrees radians is going to be pi over 3. Okay, the next one also is going to be in quadrant 4 as well, right here. It's going to be the same angle. This way here is theta hat, because it's 1/2 this way, right? So it's going to be 190, 180, 270 plus that's 30, so it's going to be 300. So x equals 300 degrees, or what's it going to be? 7 pi over 6? No, it's going to be 11 pi over 6? No, 7 pi over 3. No, 5 pi over 3. Okay, I had to go from degrees to radians. Easy way to remember something like this is very simple. Well, I know that pi over 3 is equal to 60 degrees. I also know that pi over 6 is equal to 30 degrees. The 3 and the 6 always interchange. So if it's pi over 3 here, that's 60 degrees times 5 is 300. That's how I got it. Okay, right here. Pi over 3 is 60, right over here. Times 5 is going to be 300 degrees. Okay. Next question. Oh, so these are your two answers. Pi over 3 and 5 pi over 3 in radians. Last question. How do we solve this out? First of all, we know that tangent sine of x is equal to tangent of x, which is going to be sine of x over cosine of x. If you have something that's equal to another ratio, just put over 1, cross multiply. Sine of x times cosine of x is equal to sine of x. And then what we want to do is we want to set it equal to 0 and use a zero product property. So you have to move sine of x to the left side by subtracting sine of x to both sides. You end up with sine of x cosine of x minus sine of x is equal to 0. At this stage, you have a sine of x here, sine of x here, so you're going to factor out sine of x. You're going to have cosine of x minus 1 equals 0. If you're not sure about that minus 1, distribute, and you should end up with the previous problem, right? Using the zero product property, you set each factor equal to 0. Sine of x equals 0. Cosine of x minus 1 equals to 0. So we set the first factor equal to 0. Factor means something that's being multiplied. We set that factor, because these are being multiplied, equal to 0. When does it equal 0? When does the sine, the y value, equals 0 between 0 and 2 pi? If you use a unit circle like this, 1, 0, 0, 1, -1, 0, and then 0, comma, -1. So on the y direction, it goes 0 at here. I'm going to use green pen. The sine value equals 0 at y value here and here. So it's going to be 0 and pi. This is pi radians, straight across. And then let's solve for this guy, this equation. Excuse me, cosine of x equals 1. Where does it equal 1? It's going to equal 1 at here, at 0. At x equals 0 degrees or radians, or 0 radians as well. Get the unit circle down for this one. Okay, make sure you know these four, they might come out a lot. okay, on the unit circle. So that's it. Good luck, guys.